Hello everyone, welcome back. This is part 12 of the design patterns tutorial. In this session, we will do a quick recap of previous session and will discuss how to implement the builder design pattern. We strongly recommend you to refer to the previous parts of the tutorial before proceeding. In the previous session, we have implemented the business requirement of configuring the systems allocated to the employees without using any design patterns. Now let's assume that we have a new requirement of choosing the system configurations based on the computer type that we need to build. Let's say we need to choose different type of configurations for the laptops and desktops that are allocated to the employees. For example, a laptop user can choose touchscreen as a configuration, whereas desktop users can configure keyboard and mouse. As discussed earlier, the current implementation, which we adopted in the previous session, becomes complex and complicated if we do not choose any creational design pattern over here. In our case, since we are building the system configuration in a step-by-step process, builder design pattern suits our requirement. First, let's see how we can migrate the current code to the builder implementation. Once it is achieved, we will address the additional requirements as mentioned here. Let's now switch to Visual Studio and implement the solution using our previous working example. Let's start decoupling the computer system class that we have built in the previous session of builder design pattern. First, let's create a folder under this web project, add new folder, and name this folder as builder. Let's create another folder under this builder folder, add new folder, and name this folder as product. The end product that we are going to build is the computer system, and we have already created computer system class in the previous session. Let's move this computer system class to this product folder. Let's create another folder under the builder folder, add new folder, and name this as iBuilder, which holds the interfaces related to the builder design pattern. Let's create add new item, and let's add an interface, and let's name this interface as iSystem Builder. Since we are building the system configuration, we are choosing the name as iSystem Builder. On another note, to simplify the builder design pattern explanation and to match the explanation with the representation diagram that we have used in the previous session, I'm following this folder structure. However, please feel free to come up with your own way of defining the classes based on your requirement. The main purpose of this iSystem Builder is to build the system in a step-by-step process, and finally, it should return the object once it is built. Let's say while building the system, we need to add memory. So let's create a method, interface method, void add memory. Let's pass the parameter as memory. Let's create another method to add drive size, void add drive, which accepts the drive size as the input parameter. Once the builder builds both of the required configurations, at the end we need to return the build system, which is our computer system. So let's add another method which returns computer system and name this method as getSystem. Let's now switch to the computer system and eliminate the constructor with parameters and change these private properties to public so that these are set from the concrete builder classes. Let's change this to public. Let's also remove this underscore RAM and rename this as RAM, and let's set the properties for this RAM as get and set so that it becomes a public variable. Let's also change this to public and rename the HDD size, remove the underscore, and assign get and set properties for this. Let's now add concrete builder classes which implements the iSystem Builder. Right click on this builder folder, add new folder, and name this folder as concrete builder. Let's add a class, add new item, choose a class, and name this class as desktop builder. Let's add another class, add new item, choose the class. Let's name this class as laptop builder. Let's inherit the interface iSystem builder. Let's resolve this issue by using web.builder.iBuilder. Let's also implement the interface methods. Implement interface. The purpose of this laptop builder is to build the system configurations and return the computer system which is being built. So let's create a computer system object, and name it as laptop, since we are building a laptop, equal to new computer system. In the add drive, let's say laptop dot HDD size equal to size. Let's assign the properties for the laptop. For memory, it will be laptop dot RAM equal to memory. Once these two configurations are built, let's return the laptop here. Return laptop. Let's now switch to the desktop builder and implement the iSystem builder. To make the things faster, I have already implemented the iSystem builder in the desktop builder class. The only difference is we are building a computer system which is a desktop over here, and we are returning the desktop once the configurations are built. Now, as per the enhancer requirement, let's say we need to provide an option to add keyboard and add mouse as the configurations for desktop, and we need to add touchscreen as the configuration for laptop. Let's switch to the iSystem builder. Notice that adding memory and drive are the common configurations for both desktop and laptop. Let's add few more methods to the iSystem builder to address the enhancer requirements. For desktop, let's say we need to choose the type of keyboard and mouse, which should be either wireless or a regular USB mouse. So let's add those methods as void add keyboard, and which accepts string type as the input parameter. Let's also say add void add mouse, which accepts the type of the mouse as input parameter. Let's now add another method, void add touchscreen, with input parameter as string enabled. It says whether the touchscreen is enabled for the laptop or not. Let's now switch to the desktop builder, and notice that iSystem builder is showing a compilation error. So let's fix this error by implementing the missing methods. Now in the add keyboard, we need to assign the keyboard type. To assign the keyboard type for the computer system, let's switch to the computer system and add properties to the computer system. The properties would be string keyboard, add another property string mouse, and let's add another property string touch screen. Let's now switch back to the desktop builder and assign these properties here. Let's say desktop dot keyboard equal to type of the keyboard. Let's also do the same thing for add mouse as well. Desktop dot mouse equal to type of the mouse. Now touchscreen doesn't make any sense for the desktop builder, so let's just do a return here. Let's now switch to the laptop builder. To make the things faster, I have already implemented the new methods of the iSystem builder in this laptop builder. Notice that I have added touchscreen as a property and using a return statement for keyboard and mouse, as it doesn't make any sense using keyboard and mouse for a laptop builder. Let's create another class that controls the way builder is executed. In some situations, building a product has to follow specific steps, and the class that directs those specific way of execution is called director. Let's create a folder called director that builds the system using iSystem builder and the collection of parameters that's being passed. Let's create a folder in a class, right click, add new folder, and call this folder as director. And let's add a class, right click, add new item, and call this director class as configuration builder. Let's add a method build system with iSystem builder and name value collections as the input parameters. To make the things faster, let me copy the code which I have already written from my notepad. The iSystem builder is an interface which represents either the laptop builder or desktop builder in the runtime, whereas the name value collections are the configuration chosen for these concrete builder classes from the front end. Now that we are building the system in the configuration builder, let's switch to the computer system and remove the build method that we have created in our previous session. To make the things faster, I have created two views for laptop and desktop under the employees view folder. Along with the common configurations such as RAM and hard disk, I have provided an option to choose touchscreen in the laptop view, whereas in the desktop view, I have provided an option to choose keyboard and mouse types. You may be wondering why we need to create two new views. To answer that, it's not mandatory to create two new views, and we can leverage on creating these two system types as partial views and embed them in the main builder system view. However, to make the thing simple, I have created two new views. Now on submit click, we are submitting the views to the respective controllers. Let's switch to the employees controller. To make the things faster, notice that I have already enhanced the build system action method which we have created in the previous session. The build system will return the respective views of desktop and laptop based on the system type allocated to the employees. I have also added two new action methods which are build laptop and build desktop. Let's take a closer look at and inspect the code of the build desktop action method that I have already created. Notice that in the first step, we are retrieving the employee details, and in the second step, we are creating the instance of the system builder, which should be either desktop builder or laptop builder. In our case, we are creating a desktop builder here. In the third step, we are creating the director object and passing the concrete builder and the form collection, which is a configuration chosen from the respective view. The director is responsible to build the system, and once that is done, in the fourth step, we are returning the computer system which has the details assigned as the properties. At the end, we are saving the configurations to the system configuration details column of the employee table. Let's now run this application and see these changes in action. Let's choose Employees tab. Let's click on Build System of Sebastian, who has got desktop. Notice that the moment we click on the build system, it is presented with the desktop view. Let's choose the memory, 16 GB, drive as 500 GB, mouse as a wireless mouse, and keyboard as a regular USB keyboard. Let's click on create. Look at that, we have successfully built the configuration of the Apple desktop which is allocated to Sebastian. Let's do the same thing with Andrew, who is the manager. Let's click on the build system. Look at that, we are presented with the laptop view. Let's now choose the memory as 8 GB and the drive as 500 GB, and let's choose touch enabled as yes. Let's click on create. Notice that we have successfully built the system configurations of Andrew, who is a manager and holds a Dell laptop. With this, we have successfully addressed the requirement by using builder design pattern. I hope now you got familiar with the builder design pattern. Let's now switch to the builder design pattern representation diagram. Notice that the product in the left part of the diagram corresponds to the computer system, whereas the builder corresponds to the iSystem Builder class. We have created two concrete builders, which are our desktop and laptop builders, which corresponds to the concrete builder in the left side. Configuration builder is the director in our case and is represented in the left part of the diagram. In the next session, we'll discuss how to implement Fluent Builder, and we'll also discuss the differences between factory and the builder design pattern. Thank you for listening and have a great day.